This is my lab report 2. In this experiment, we will observe the motion of an object that is dropped from rest and falling somewhat slowly straight down. Somewhat slowly means slowly more slow than a rock drop from rest at the same height. So I decided to use a coffee filter to observe the dropping motion. I use Tracker to see this motion. So let's go to Tracker. So here you see the coffee mug being dropped. The mass of the coffee filter is 0.009 grams. We will create some models to determine the effects of gravity and how it affects the object and how gravity and drag will affect the object. We will use Newton's second law. So velocity final is equal to velocity initial plus F net over magnitude times delta t, and the position, which is position final, is equal to position initial plus velocity times delta t. And we will also look at F net, which is F gravity in one of them, and force gravity plus force drag for the second compositional model. So I used GlowScript to find my predicted. So here is my code. The mass is 0.009, and when we run it, this is what we get. The velocity over position. Position and time graphed. And it went to 1.2 seconds. So I made this graph in Excel to model the effects of gravity only. This demonstrates Newton's second law by using F net to be equal to just gravity. You can see that it is off by a bit from the observed and the predicted. And this is because drag isn't taken into consideration. So here's the other model with the gravity and drag. So we use Newton's second law to calculate the predicted position with the data that we collected from Tracker, and created this graph by incorporating drag into F net. The drag force is opposite to the direction of the object's motion and has the magnitude proportional to the square of the object's speed. So we use this all into consideration when creating this model into Excel by using Newton's second law's equation. Here we are comparing the models. So here are the three models that were made, which was the first one, the observed data, which is the purple. Then we have the predicted with gravity and drag, which is the green, and the predicted with gravity only, which is blue. So with the what does it mean question, we look at the terminal velocity, which is the force of drag pointing up has exactly balanced the force of gravity pointing down. They both show terminal velocity, but the graph shows net force being gravity plus drag force. The what if question was if we threw the object downwards instead of dropping it, would the terminal velocity be the same or different? So the object would have a greater terminal velocity, meaning it would reach the ground faster. The velocity would be faster, meaning it would have a steeper slope in the velocity versus time graph in comparison to the original one that is shown here. Thank you.